Okay, this is notes 1.5, algebraic properties of limits and piecewise functions. So first off, let's start with what is x plus x? Okay, so x plus x is 2x. Okay, well, what if we had the limit as x approaches c of f of x plus f of x? Well, f of x plus f of x is just 2f of x, so this is the limit as x approaches c of 2f of x. Okay, and anytime we have a constant or a coefficient inside of our limit, we can simply take it out. So this is the same as saying 2 limit as x approaches c of f of x. Okay, so knowing that property, we're going to look at the example below. So it says, it gives us the following limits, and it says the table above gives selected limits of the function f and g. What is the limit of the following? Okay, well, the first thing we need to do is write this out. So we first are going to separate this into two limits. So we have the limit as x approaches 1 of f of negative x, okay, plus, since we have divide by 2, that's technically a constant that we can take out. So plus 1/2 limit as x approaches 1 of g of x, okay. This f of negative x is a composite function, okay? So really what this is telling us to do is find the limit as x approaches -1 of f of x, then the rest can come down. So again, this is using our properties of limits. So now that we have that situated, the limit as x approaches -1 of f of x, that's this value here, so that's going to be 2. Plus 1/2, and then the limit of x approaches 1 of g of x is 6. Okay, so times 6. That is this part here. And so if I simplify that, 1/2 of 6 is 3. 2 plus 3 is 5. So the limit of this composite function is going to be 5. Okay, example 2 says the graph of the function f is shown on the right. What is the limit as x approaches 4 of f of x? So remember, first we're going to find the limit as x approaches 4 of f of x. That is this inside function here. Okay, so f of x is over here. As it approaches 4, that's right here. Notice that from the left and the right, it's both approaching 1. So then I'm going to do the limit as x approaches 1 of f of x. This is now that outside function, and that 1 came from the answer of our previous one. Okay, so now looking at 1, okay, again, from the left and the right, here's the left, here's the right, we get -1, which means -1 is our answer to the limit above. Okay, example 3 says the table above gives selected values and limits of the functions f, g, and h. It wants us to evaluate the following. So first I have to separate it. So this is the same as saying the limit as x approaches 5 of h of x. Okay, and then I can actually rewrite f of x and g of x to have the limit expression as well. So the limit as x approaches 5 of f of x plus 2 limit as x approaches 5 of g of x, because I took out that constant, minus h of 5. Okay, so from here, I need to identify what these values are. So the limit as x approaches 5 of f of x, so that is 6. Of g of x is -1. H of 5 is 3. So I got to plug that in so far. So I have the limit as x approaches 5 of h of x. Or wait, I already have that there. I didn't highlight it right here. The limit as h of x, that's this. That's 5. So I have 5 bracket 6 plus 2 times -1 minus 3. So this gives me 2 and -1 is -2, plus 6 is 4, 5 plus 4 is 20. 20 minus 3 is 17. So the answer to that limit is 17. Okay, example 4 gives us piecewise functions, and it wants us to answer the following. So it says the limit as x approaches -5 from the left of f of x. So notice the left would be this expression here because this is x less than -5. So I would plug in -5 into that expression. So this is the square root of 11 minus a -5, which is the same as saying the square root of 16, which is 4. Okay, now from the right side, which would be the other side, I would plug in -5 into the one I highlighted in green. Okay, so I have -5 plus 3, which is -2. 5 minus 25, which is -20, which gives me 1/10. And then notice I have the overall one. So if my limit from the left does not match my limit from the right, then I say the limit does not exist. Okay, so let's look at this last piecewise. So we have the limit of g of x as x approaches -1. So we have to look at both sides of -1. Okay, so we're going to look at this side and this side. So I have the square root of 10 minus -1 squared. So that's going to be the square root of 9, which is 3. Okay. Then I have 26 minus 5 times -1 squared over 7, which that would be 5. So 21 over 7, which is 3. So notice how both the left and the right side are 3. So the limit overall as x approaches -1 is also 3. Okay, let's look at the limit as x approaches e from the right side. So from the right side would be this value here because it's greater than e. And so this would be simply us going natural log of e cubed. By the properties of natural log, that 3 can come in the front. So this is 3 natural log of e. Natural log of e cancel each other out, so our answer is just 3. And then it wants us to find the limit as x approaches e of g of x. So we already have the right side, and so now we need the left side. Okay, and the left side would be using this one. So we have 26 minus 5 times e squared over 7. Remember, e is a number. It's like 2.71, blah, 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 blah. Okay, so there's no way that this, which is a decimal, is going to end up giving us that perfect 3. So this does not equal 3. And so this tells us that since the limit as x approaches e from the left of g of x doesn't equal the limit as x approaches e from the right of g of x, that the limit as x approaches e of g of x does not exist.